Welcome to efinanceacademy.com. The topic we have today is common probability distributions. So in this topic, we will talk about two types of random variables. We'll discuss discrete random variable, and under this type of random variable, we'll talk about two types of distributions: uniform distribution and binomial distribution. We'll also discuss continuous random variable, and we'll be looking at uniform distribution and the normal distribution. Finally, we'll end the reading with Monte Carlo simulation. So, as you may recall, we earlier discussed what a random variable is. A random variable is any variable with uncertain outcome or quantity. For example, if you toss the coin, the outcome on the coin toss is a random variable because we don't know whether a head will happen or will we get a head or a tail. Likewise, the return on a stock, the monthly return, let's say, or the daily return on a stock, or the daily price of a stock, all these are examples of random variable because we don't know exactly what will the outcome actually be. Now, random variables can be divided into two types. You have one that is called discrete random variable, and you have another type called continuous random variable. A discrete random variable is the one where is that random variable where the outcomes of the random variable are countable. So while it's random, but the number of outcomes that it can take, that the random variable can actually take, are countable. So we have countable outcomes. For example, the example I gave you, that of a coin toss, when you toss the coin, the result or the outcome will be random, but we know what are the possible outcomes that the coin toss can actually have. It's only two. It's either head or tail. Likewise, if we roll the dice, the number of outcomes that we would get on a dice would be maximum of 6. Hence, it's again a discrete random variable. On the other hand, what is a continuous random variable? It can take on uncountable number of outcomes. So the number of outcomes with continuous random variable are simply uncountable. All right, another example we could actually look at for discrete random variable would that be of stock prices. So when we speak about stock prices, they are generally considered, so a distribution of stock prices would generally be considered as discrete distribution, because the number of possible outcomes or the number of possible prices on any single day, for example, are actually countable. And why is that so? So let me give you the reason for that. So the stock prices are generally, data of stock prices would generally be considered as discrete, although it can be modeled as continuous as well. But firstly, why is that discrete? So, well, first thing, let's say, so we are in a market where there is an upper limit and there is also a lower limit. So the upper and lower limit, let's say, is plus minus 10%. Which means stocks cannot go on any single day above 10%, and they cannot, the stock prices cannot fall below more than 10%. So these are the upper and lower limits. And let's also say we have a stock that has a price of $10 right now. And you will also see more in most of the markets that the stock price will have a certain minimum tick size, which is the minimum movement size that is defined. So let's say the tick size is defined as, for the sake of simplicity, let's say that's 50 cents or $0.5. That means the stock price will move at least by the minimum size of $0.5 every time it actually, the stock price changes. So currently the stock price is 10, let's say at the beginning of the day. And the maximum it can go up is by 10%, which means it can go up by $1, or the maximum it can go down is it can go down by $1. But what is the minimum movement size? Which is 0.5. So from 10, it can go up to 10.5, and from 10.5, it can go up to 11, right? So these are the possible prices on the upper side. From 10, it can go down to 9.5 because that's a minimum movement size of 0.5, or the lowest it can go down to is 9 because limit would actually apply then. So notice, what are the possible prices of stock on any given day? As you can see, you can count the maximum possible prices with these assumptions that we have made will actually be 5 possible prices. Hence, a stock prices distribution or data of stock prices would actually be considered as discrete, although even stock prices can be modeled as continuous as well. So on the other hand, we said that stock returns, so stock returns are continuous. So stock returns are example of a continuous random variable. Think of it like this. Let's say another example we could look at is if we were to say, what are the number of days that it can rain in a week, and the maximum number of days it can rain in a week are 7, hence that's discrete. On the other hand, if we say what is the amount of rain in a week, that will most likely be a continuous because it's a large number and it cannot be counted. The reason why stock returns are continuous and they're uncountable, even if we say that on a daily basis, the maximum return could be plus minus 10%, as we said before, but you can have an outcome that could look like this 7.77%. This could be one return. Then another return could be 7.7776. And that's unique. This is unique outcome and this is unique outcome. So you can have so many returns, and hence the number of most likely returns that you will have, even if there is a cap or there are limits, yet you cannot count the number of possible outcomes that returns can actually that stocks can have. So stock returns are an example of continuous random variable. All right, so when we speak about discrete, we'll elaborate on this in more detail. We have two types of discrete distributions. We have one which is called discrete uniform distribution. That's called discrete uniform distribution. What does discrete uniform means? Discrete, as we said, are countable outcomes, while uniform means equal chance, so equal likelihood, which means each and every countable outcome has an equal chance of happening, has an equal probability of happening. For example, if there are 2 outcomes, it will be 1 divided by 2, which means 50-50. If there are 4 outcomes, it will be 1 divided by 4, and so on. And the other type of distribution that we have is called binomial distribution. And by the word binomial, we actually mean 2 possible outcomes. So if you have a distribution in which you will always have 2 possible outcomes in every trial, such as one is often labeled as success and the other one is labeled as failure. So that's basically called binomial distribution. All right, so let's understand the discrete uniform distribution in more detail, and then we'll be discussing the binomial distribution as well. So discrete uniform distribution, as we said, is each and every countable outcome has an equal probability of happening. So let's say if I roll the dice, and we know the number of outcomes could range from 1 to 6. And so let me write here outcomes. And let's say outcomes are represented by symbol X. And what you see here, P bracket X, is a probability function. This is the probability of outcome X. So for example, we could, if we roll the dice, the outcome could be either 1, 2, 3, 4, 5, or 6. And what is the probability of 1 getting an outcome 1? So what is P1? The probability of getting 1 is 1 out of 6, which is 16.66%. What is the probability of getting an outcome 2, which is a single outcome? Again, it is 16.66. So the probability of getting outcome 3, P3, would be 16.66, and so on. And of course, it should add up to 100%. So Px represents the probability of outcome X. We also have cumulative distribution function. While this is probability function, we have something called cumulative distribution function, which is Fx. So what does F1 mean? F1 means the probability of getting 1 or lower. What does F2 mean? The probability of getting 2 or lower. Of course, we're just simply going to add them up, or 2 or lower means 2 outcomes. 2 outcomes out of 6 will be 2 divided by 6. So the way we can get F1 is just simply 16.66 because the probability of getting 1 or lower is 16.66. F2 will be the probability of getting 2 or lower. We just simply add 16.66 plus 16.66, which is 33.32. Or alternatively, we can say there are 2 outcomes, as you can see, 1 and 2. 2 outcomes out of a total of 6, so 2 divided by 6. Likewise, what is the probability of getting 3 or lower? We add all these 3, and what we get is 49.98, or simply we say 3 out of 8. And then we continue like that. This will be 66.64. Probability of getting 5 or lower is 83.3. And finally, this should always be equal to 100%. So that's how you are actually going to do the calculation. All right, now if I were to ask you some related questions to this, so let's say if we say, what is the probability of getting 3 or lower? So we could write the question in this way. We could say the first question is, what is F3? So we could write it as F3, or alternatively, this could also be written as, what is the probability that X will be less than or equal to 3? That's exactly what we said. This is the cumulative probability. So F3 can be written as Px is less than or equal to 3. And what did we say? How do we find that? We said all we do is simply add the probability of 1 to probability of 2 to the probability of 3, because that's what it means. Probability of getting an outcome 3 or lower. So all we are simply going to do P3 plus P2 plus P1, which we have already done. And what we found was it's 49.98, or you might say 16.66 plus 16.66 plus 16.66, which is 49.98. We also said you can calculate it as 3 outcomes out of a total of 8, and that should give you your answer. All right, next question is, let's say our next question is, what is the probability of getting an outcome, let's say, so that the X will be greater than or equal to 2, but less than or equal to 4. So what is the probability that X will be greater than or equal to, so it equals means we are counting 2 as well, to 2, but less than or equal to 4. So there are, how many outcomes are there in this statement? If you see, we have an outcome 2 because we are saying equal to 2, 2, 3, and 4. So all we will just simply do is we will add the probability of P2 plus P3 plus P4, right? That's what we will do, and we will actually get the answer. Now, sometimes what they might do is they might not give you these probabilities, which is P2, P3, and P4. This might not be given, rather cumulative probabilities would be given, and you would be asked to find this. So how would you actually answer this in that particular case? If you are given only cumulative probabilities and you're asked to find what is the probability that X will be greater than or equal to 2 and less than or equal to 4. And the answer to that lies, we can find, if you're given cumulative probabilities, then we would say F4, which is cumulative probability of 4, which is 66.64, minus F1. Why not F2? That's the question that might arise. Why don't we take F1? Why don't we take F2? Rather, why do we take F1? Because we want to include 2. So when we subtract 1, that means we are counting ahead of 1, right? So that's what we are doing. Or let me put it this way. Here is how you can understand what is actually F4. Notice F4 is P4 plus P3 because it's cumulative probability plus P2 plus P1, right? While F1 will just simply be the probability of 1 only. So when we subtract F4 minus F1, this and this cancels out. What we are left with is only P4, P3, P2, which is exactly what we wanted, P4, P3, P2. So you're not going to subtract f4 minus f1, f4 minus f2, rather you're going to say f4 minus f1 because there is an equal sign with 2, which means we are going to include 2 as well. So in simple way, we can find f4 minus f1. We will say 66.64 minus 16.66, and that will give us the answer of the probability that x is more than or equal to 2 but less than or equal to 4, which is around 49.98. So that's our second question. That's how you would actually answer. Let me now ask a third question and a final one related to this, which could be more like, what is the probability that x will be, so let's say x will be more than 2 but less than or equal to 4. Now there is no equal sign here, which means we will not count. We're saying more than 2. More than 2 means 3 and 4. So in short, what we are saying, what is the probability of getting 3 plus the probability of getting 4? So now we are not counting 2, right? So how will we answer this? If we are given cumulative probabilities only, then we are just simply going to say, f4 minus f2. That means when we are subtracting f2, we are counting ahead of 2, which is 3 and 4. So that's how we will get our f4. That's how we'll get our probability that x is more than 2 but less than 4. All right, so this is just simply going to be 66.64 minus f2 is 33.32. And that should give us the answer, which will be around 33.32. Put it this way, here's what we are saying. f4 is equal to p4 plus p3 plus p2 plus p1, while f2 is equal to p2 plus p1. So when we are subtracting these two, this cancels against this and this cancels against this, and we are left with p4 and p3, and that's exactly what we actually wanted. So this is how you will actually do the this is how you will calculate the probabilities if you are ever asked questions like these. Make sure you understand properly what is fx and what is px.